All right, let's get started. Getting started, quickly set up a Rust development environment and write a small app. Okay. Installing Rust. Buy Rust without installing. How do you buy without installing? No, we will install it. Uh-uh. Mm-mm. This is the one, right? The primary way to that folks install Rust is through a tool called RustUp, which is a Rust. Where was I? Which is a Rust installer and version management tool. It looks like you're running Mac OS, Linux, or another Unix like OS. To download RustUp and install Rust, run the following in your terminal, then follow the on screen instructions. Blah blah blah. Okay, we've got a terminal. Hmm. Proceed with standard installation, customize installation, cancel installation. Let's go with standard. It's our first day. Hmm. Okay. Installing. All right. We're in. To configure your current shell, you'll need to source the corresponding env file under home Argo. This is usually done by running the following. Note the leading dot. Okay. Take this. Font a bit. So we, I think we're ready. Update. Update is like Linux. To do apt update. Thinking channel updates for stable arch. Before Apple Darwin and for checking for self update. I think we're good. What else? When you install Rustup, you'll also get the latest stable version. Build your project with cargo build, cargo run test. That is all fine, but learn. Book. Load it. Getting started. Installation we've done. Installation. Let's go to hello. Now that you've installed Rust, it's time to write your first program. It's traditional when learning a new language to write a little program that prints the text hello world the screen, so we'll do the same. Okay, create a project directory. Okay, get this up. Okay, dir text cd text. Okay, world. Okay, we're in. Writing and running a Rust program next. Make a new source file and call it main.rs. Okay, we'll do touch main.rs. Then Rust files always end with the .rs extension. If you're using more than one word in your file name, the convention is to use an underscore. Okay, I understand. Now open the main.rs file you just created and enter the code in listing 11. Okay, we'll do nvim main.rs. Rn. All right, do this. Do function main. Type it, right? And we'll be able to do. God, how do I exit this? Also new with NeoVim. Haven't configured it at all. Do it later. First we run the hello world program print ln. Okay, you do print ln and what? Exclamation mark. Then parentheses. Quite something quite similar to we do in JavaScript, except that ln and exclamation mark. So world. I'll write something extra. This is tired kebab. Semicolon. Is it compulsory? I think it is. Okay. Save the file and go back to your terminal window in on Linux and macOS. Enter the following commands to compile and run the file. Okay. We'll write and quit. A rust c main dot rust c is rust compiler, I guess. Main dot okay. Then full stop / the file just main. Okay. Voila. Got it. Now, next thing, regardless of your operating system, the string hello world should print to the terminal. If you don't see this output, refer back to the troubleshooting part of the installation. We see it, so we don't need to. If hello world did print, congratulations, you've officially written a Rust program. And that makes your Rust program welcome. Thank you. Don't mind if I do. Anatomy of a Rust program. Let's review this whole hello world program in detail. Here's the first piece of the puzzle. Function main. These lines define a function named main. The main function is special. It is always the first code that runs in every executable Rust program. Here, the first line declares a function named main that has no parameters and returns nothing. If there were parameters, they would go inside the parentheses. The function body is wrapped in curly braces. Rust requires curly brackets around all function bodies. It's good style to place the opening curly bracket on the same line as the function declaration, adding one space in between. Okay, cool. If you want to stick to a standard style across Rust projects, you can use an automatic formatter called Rust FMT to format your code in particular style. Okay. The body of the main function holds the following code. Print ln hello world. This line does all the work in this little program. It prints text to the screen. There are three important details to notice here. First, print ln exclamation. That is okay. All the Rust macro. If it had called a function instead, it would be entered as println without the bang. Rust macros are a way to write code that generates code to extend Rust syntax, and we'll discuss them in more detail in chapter 20. Okay, you gotta wait to. For now, you just need to know that using a exclamation mark means that you're calling a macro instead of a normal function, and that macros don't always follow the same rules as functions. Second, you see the hello world string. We pass the string as an argument to print ln, and the string is printed to the screen. Okay, third, we end the line with a semicolon, which indicates that this expression is over and the next one is ready to begin. Most lines of Rust code end with a semicolon. Compiling and running are separate steps. You've just run a newly created program, so let's examine each step in the process. Before running a Rust program, you must compile it using the Rust compiler by entering the rust c command and passing it the name of your source file like this, rust c main rs. But here we only typed rust. Okay. Hmm. Okay. If you have a C or C++ background, which I don't, you'll notice that this is similar to GCC or Clang. I heard about GCC, but not Clang. After compiling successfully, Rust outputs a binary executable. On Linux, macOS, and PowerShell on Windows, you can see the executable by entering the ls command in your shell. Okay, let's see. Do I see ls? Hmm. Can I cat this? Oh. It is binary, that's why. So much for just hello world. Cool. Okay. What next? We don't need all this. Let's say CTU files, PowerShell and Windows, you'll see the same three files. Okay. This shows the source code file with the .rs extension, the executable file main.exe on Windows, but main on all other platforms. And when using window, a file containing debugging information with the .pdb extension. From here, you run the main or main.exe file like this. You need to know about Windows. If your main.rs is your hello world program, this line prints hello world to your terminal. If you're more familiar with the dynamic language such as Ruby, Python, or JavaScript, yes, I am with JavaScript. You might not be used to compiling and running a program as separate steps. Yes, I'm not. Rust is ahead of time compile language, meaning you can compile a program and give the executable to someone else and they can run it without having Rust installed. If you give someone a .rb, .py, or .js file, they need to have a Ruby, Python, or JavaScript implementation installed respectively. But in those languages, you only need one command to compile and run your program. Everything is a trade-off in language design. I can only agree. I don't know much. Just compiling with Rust C is fine for simple programs, but as your project grows, you'll want to manage all the options and make it easy to share your code. Next, we'll introduce you to the Cargo tool, which will help you write a real world Rust programs. Okay, we're getting into the real world. Hello, Cargo is Rust's uh, build system and package manager. Most Rustaceans use this tool to manage their Rust projects because Cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, and building those libraries. We call the libraries that your code needs dependencies. I'm familiar. The simplest Rust program like the one we've written so far don't have any dependencies. If we had built the Hello World project with Cargo, it would only use the part of Cargo that it handles building your code. As you write more complex Rust programs, you'll add dependencies, and if you start a project using Cargo, adding dependencies will be much easier to do. Because the vast majority of Rust projects use Cargo, the rest of this book assumes that you're using Cargo too. Cargo comes installed with Rust if you use the official installer discussed in the installation section. If you've installed Rust through some other names, check whether Cargo is installed by entering the following in your terminal. We can check cargo hyphen hyphen version. You got it. If you see a version number, you have it. If you see an error such as command blah blah blah, we don't have an error. Creating a project with Cargo. Let's create a new project using Cargo and look at how it differs from our original Hello World project. Navigate back to your project's directory or whatever or wherever you decided to store your code. Then on any operating system, run the following: Cargo new hello Cargo. Cargo new hello cargo, right? I don't have to follow the naming, but nice. Okay, what do we got? cd hello cargo. Oh, it's installed Git already. Nice. The first command creates a new directory and project called hello cargo. We've named our project hello cargo, and cargo creates its files in a directory of the same name. Go into the hello cargo directory and list the files. You'll see the cargo has generated two files and one directory for us, cargo.toml file and a directory with our main.rs file inside. Okay, you got it. um it has also installed a new git repository along with the .gitignore file. We'll see. Yeah. Hmm. Git files won't be generated if you run cargo new within an existing git repository. You can override this behavior by causing cargo new version control system equals git. It is common version control system. You can change cargo new to use different version control systems or no version control system by using the VCS flag. Okay. Open cargo.toml in your text editor of choice. It should look similar to the code listing one too. Okay. nvim cargo.toml. Package name equals to hello cargo version 0.1.0 edition 2024. Hmm. Didn't say anything like this. Okay, we got here. Okay, the file is the toml Tom's obvious minimal language format. Is it what toml is? Tom's obvious minimal language format, which is cargo's configuration format. Tom's obvious minimal language range. The first line, the first line package is a section heading that indicates that the following statements are configuring a package. As we add more information to this file, we'll add other sections. The next three lines set the configuration information. Cargo needs to compile your program, the name, the version, and the edition of Rust to use. We'll talk about the edition key in Appendix E. The last line, dependencies, is the start of a section for you to list any of your project's dependencies. Um, In Rust, packages of code are referred to as crates. We won't need any other crates for this project, but we will in the first project in chapter 2. So we'll use this dependency section then. Now open source main.rs and take a look. Okay, source main.rs. Okay, we've got hello world function here. Cargo has generated a hello world program for you, just like the one we wrote in listing one. So far, the differences between our project and the project cargo generated are that cargo placed the code in the source directory, and we have our cargo.toml configuration file in the top directory. Cargo expects your source files to live inside the source directory. The top level project directory is just for readme files, license information, configuration files, and anything else not related to your code. Using cargo helps you organize your project. There's a place for everything, and everything is in its place. If you started a project that doesn't use cargo as well with the hello world project, you can convert it to a project that does using cargo. Move the project code into the source directory and create an appropriate cargo.toml file. One easy way to get that cargo.toml file is to run cargo in it, which will create it for you automatically. Building and running a cargo project. Now let's look at what's different when we build and run hello world program with cargo. From your last hello cargo directory, build your project from your Hello cargo directory. Build your project by entering the following command: cargo build. Okay. Exit this. Okay. Cargo build. Compiling hello cargo. This is the path. And finish dev. Optimized. Debug info targets. Give me a minute. Okay. Cargo build is the only command and the rest is this. This command creates an executable file in target slash debug slash hello cargo or target slash debug slash hello cargo.exe on Windows. I don't want to know about Windows. Get about Windows. Rather than in your current directory. Why? Because the default build is a debug build. Cargo puts the binary in a directory named debug. You can run the executable with this command. What is this? Okay. If it all goes well, hello world should print to the terminal. Running cargo build for the first time also causes cargo to create a new file at the top level, cargo.log. I've got it. Okay. This file keeps track of the exact versions of dependencies in your project. The project, this project doesn't have dependencies, so the file is a bit sparse. Can we open cargo.log? Cat cargo.log. This file is automatically generated by Cargo. It is not intended for manual editing. Version equals to 4 package name hello Cargo. Okay. Hmm. Okay. You won't ever need to change this file manually. Cargo manages its contents for you. We just built a project with Cargo build and ran it with this, but we can also use Cargo run to compile the code and then run the resultant executable all in one command. Cargo run. Okay. Cargo run. Set compiling finish. Is it because it also already compiled manually? Touch. What is the file name? rc main.rs. Okay. rc. And if we now cargo run, okay, we're getting there. We just built a project with cargo build and ran it. Okay. Using cargo run is more convenient than having to remember to run cargo build and then use the whole path to the binaries. So most developers use cargo run, which is sensible. Notice that this time we didn't see output indicating that Cargo was compiling hello Cargo. Cargo figured out that the files hadn't changed, so it didn't rebuild, but just ran the binary. If you had modified your source code, Cargo would have rebuilt the project. before running it, and you would have seen this output. Cargo run with this. Okay, I already tried this. Going, I'm just too good. Cargo also provides a command called cargo check. This command quickly checks your code. Can we change the theme or something here? Trust full name. I think good. Let's see. Okay. Mm, mm, mm. Notice that this time we didn't see the output indicating that cargo was compiling. Hello, cargo. Okay, we got it. Cargo also provides a command called cargo check. This command quickly checks your code to make sure it compiles but doesn't produce an executable. Okay, what is it? What is this used for? Cargo check. Checking finished. What did it check? Why would you not want an executable? Often cargo check is much faster than cargo build because it skips the step of producing an executable. If you're continually checking your work while writing code, using cargo check will speed up the process of letting you know if your project is still compiling. As such, many stations run cargo check periodically as they write their program to make sure it compiles. Then they run cargo build when they're ready to use the executable. Let's recap that we've learned what we've learned so far about cargo. We can create a project using cargo new. We can build a project using cargo build. We can build and run a project in one step using cargo run. We can build a project without producing a binary to check for errors using cargo check. Instead of saving the result of the build in the same directory as our code, cargo stores it in the target or debug directory. An additional advantage of using Cargo is that the commands are the same no matter which operating system you're working on. So as it's at this point, we'll no longer provide specific instructions for Linux and macOS versus Windows. Thank God. It was okay. Okay. Building for release. I think after this I'll take a short. Building for release. When your project is finally ready for release, you can use cargo build release to compile it with optimizations. This command will create an executable in target release instead of target debug. The optimizations make your Rust code run faster, but turning them on lengthens the time it takes for your program to compile. This is why there are two different profiles, one for development when you want to build quickly and often, and another for building the final program you'll give to a user that won't be rebuilt repeatedly and that will run as fast as possible. If you're benchmarking your code running time, be sure to run cargo build release and benchmark with the executable in target release. Yeah, I'll take a break now. See you in a bit. All right, let's get back to Rust. Shall we? Do we have someone? Not now, I think. What? Okay, can close this. Okay, cargo convention. With simple projects, cargo doesn't provide a lot of value over just using Rust C, but it will prove its worth as your programs become more intricate. Once programs grow to multiple files or need a dependency, easier it's much easier to let cargo coordinate the build. Sorry. Even though the Hello Cargo project is simple, it now uses much of the real tooling you'll use in the rest of your Rust career. Hi, Tarb, how are you? In fact, to work on any existing projects, you can use the following commands to check out the code using Git to the projects directory and build. Um, well, I just started. Uh, so far it's good. I don't feel that it's too strange yet, but I know I will. I've heard good things about it. Huh. How about you? Have you ever tried Rust? Yeah, I write a good amount of Rust. It's my main language full time work for the last 6 years or so. Oh man. Senior dev in the chat, okay. Nice to have you here. Well, uh, let's see how it goes. Wish me luck. Okay, even though the Hello Cargo project is simple, it now uses much of the real tooling you'll use in the rest of your career, Rust career. In fact, to work on any existing projects, you can use the following commands to check out the code using Git, change to that projects directory and build. Okay. Nice. Yeah, yeah, we got it. Summary. You're already off to a great start on your Rust journey. In this chapter, you've learned how to install the latest stable version of Rust using RustUp, update to a new Rust version, open locally, install documentation, write and run a Hello World program using Rust C directly, create and run a new project using the conventions of Cargo. Okay. This is a great time to build a more substantial program to get used to reading and writing Rust code. So in chapter 2, we'll build a guessing game program. If you would rather start by learning how common programming concepts work in Rust, see chapter 3 and then return to chapter 2. We'll go in sequence. I don't. We're already on chapter 2. Nice. Okay. Programming a guessing game. Let's jump into Rust by working through a hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. You'll learn about let match methods, associated functions, external crates, and more. In the following chapters, we'll explore these ideas in more detail. In this chapter, you'll just practice the fundamentals. Hmm. We'll implement a uh, beginner le- classic beginner programming problem, a guessing game. Here's how it works. The program will generate a random integer between 1 and 100. It will then prompt the player to enter a guess. After a guess is entered, the program will indicate whether the guess is too low or too high. If the guess is correct, the game will print a congratulatory message. and exit. Okay, okay, simple enough. Setting up a new project. To set up a new project, go to the projects directory that you created in chapter 1 and make a new project using cargo like so. Cargo new guessing game. Okay. Um, well, okay, CD going on. Cargo guessing game. Um, Cargo new guessing game. CD guessing game. Okay. Actually, what are other languages are you more familiar? Oh, what other languages are you more with or your first time? No, I actually am a developer, so I'm familiar with JavaScript and Python. So I know fundamentals, not as deep as you would need to learn Rust. But yeah, I know the basics. Yeah, I did. So how did you end up choosing Rust as as a programming language to pursue as a career? The first non-cargo takes the name of the project guessing game as the first argument. The second command changes the new project's directory. Look at the general cargo toml file. Yeah, we'll cat. Hmm, got it. Got hired as an intern on a team that used Rust. And when I reached the team was before the job, I mainly used Java or Python. Great. Actually, this kind of happened to one of my friends as well. He got hired as a JavaScript developer, but um, his team needed Rust in the backend, so they ended up teaching him Rust as well while he was working. I like this kind of company. They teach you new things. They've created a Hello World program. Where, but where? Uh, L source NVim. Vim source. Yes. Hello World is there. Best way to do it. Get paid to learn. Yes, indeed. But I'm curious because so far whatever I've heard from friends and social media, they say Rust is really efficient in memory management stuff, and it is fast as well. Um, but uh, I'm not. Is it? Are those the Rust? Are there when although I'm learning something new? is, but my team doesn't really use it for the performance benefits realistically. We rewrote our Python system in Rust and we productivity. Ah, you're handling the confidence that you're not breaking things as you change the code base. Yes, yes, yes. This is definitely one thing that will benefit a developer the most. I mean, the compiler won't let you pass through without making the code cleaner and avoiding all kinds of pitfalls stuff. So this comes in really handy. And yes, I've read that it is um, more it makes you more productive as a developer. Okay. Yeah, I mean, even if you don't want it to be fast, it will be fast. Now let's compile this hello world program and run it in the same step using the cargo run command. Okay, so cargo run, we got hello world. Now let's uh here. The run command comes in handy when you need to rapidly iterate on a project, as we'll do in this game, quickly testing each iteration before moving on to the next one. Reopen the source main rs file. You'll be writing all the code in this file. Okay, they've given the code itself. They don't want me to guess the syntax or figure it out myself. They just want me to introduce. They just want to introduce me to the syntax. Okay, this is nice. Oh, open it again and my side quest. Oh, DJ Dev. Okay, DJ Dev. Vim. Pick. YouTube. DJ Dev. New Vim. And Tab, what ID do you use? Are you also fond of NeoVim? I'm not really proficient at it, but I really like it. Like, yeah, I know the companies they enforce to and the mainstream IDs mostly people either use VS Code or things like JetBrains or Rover Rust, etc. Okay, we need to first um, do close it. Press enter or type to continue command. That type then what I'm doing. Really good at this. I don't know why my terminal is also trouble. There's a new profile. I need to set up everything. Hmm. I'm just bad at remembering commands and shortcuts. I point and click with my mouse more often. No, I can totally relate. I mean, uh, it really depends on how much time you've got at your hands. I'm sure you're really very busy being a Rust developer. On the other hand, I'm not at the moment, so I can afford to memorize all the commands, some if not all. Okay, I think I have Git here. We do have Git. Oh, is how do I do this? I need to do Git clone better. So it sits on a shelf. Oh, yeah. Where were I? Yeah, like I bought a more Lander keyboard and it was pretty cool, but my productivity tanked like crazy while learning. Yes, it's a trade-off. So it sits on a shelf collecting dust, and I'm back to a normal keyboard. Yeah. Okay. They've cloned it now. Now we've got Linux, Max, macOS. Install it. Why don't I see the video? Let's see. Yeah. Oh, put it. I definitely. It. Oh, okay. Did I open the right link? Check out the repo. It has details. I did earlier in file. Okay, installation. Okay, we got git make zip here. How would you hide it like that, man? What's going on? Copy, 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 paste again. Okay, now if I open nvim, yeah, got it. Fine. Okay, we can do this now. Installing, installing, install. I think it's done, right? a CD projects, um, project name, CD guessing game, NVM, the telescope. Main.r. First part of the guessing game program will ask for user input, process that input, and check that the input is in the expected form. To start, we'll allow the player to input a guess, enter the code in listing 2.1 into source main.rs. Yes, sir. Write and quit. Then this code contains a lot of let's get over it line by line. Bring put output library into scope. The IO library becomes our standard library known as st. Okay, colon IO. Why double colon? No, no, no. What am I doing? I don't need to. By default, Rust has a set of items defined in the standard library that it brings into the scope of every program. The set is called the prelude, and you can see everything in it in the standard library documentation. If a type you want to use isn't included, you have to bring that type into scope explicitly with a use statement using the std io. Library provides you with a number of useful features, including the ability to accept user. Hmm. As you saw in chapter 1, the main function is the entry point into the program function main. The function syntax, fn syntax declares a new function. The parentheses indicate there are no parameters, and the curly brackets starts the body of the function. As you also learned in chapter 1, println bang is a macro that prints a string to the screen. Yes, Taub, if it's not too early for me, because this book suggests that I should learn about macros in chapter 20, which is far away. Could you give me a little hint about what macro is like? Mm-hmm. You also, okay. Println is a macro that prints a string to the screen. Println guess the number. Println please guess. Why to guess the number? Please input your guess. Let me guess. Supposed to. Or let mute guess. String. New string. Okay. Output. Dot refine mute. Guess. If you don't get an input, then you print fail to read the line. Read line. Then you print. Else you print you guessed this number. Hmm. Okay, this code is printing a prompt stating what the game is and requesting input from the user. So storing values with variables. Next, we'll create a variable to store the user input like this. Let mute it open. Let me get string. Now the program is getting interesting. There's a lot going on in this line. We use the let statement to create the variable. Here's another example. Let apples equals to 5. Hmm. Okay. This line creates a new variable, apples, and binds it to the 5. In Rust, variables are immutable by default, meaning once we give the variable a value, the value won't change. Okay, constant. We'll be discussing this concept in detail in the variables and mutability section in chapter 3 to make it variable to make a variable mutable, and we add mute before the variable. That apples 5 immutable. Let mute. Note the double forward slash syntax starts a comment at the end of the line. Rustic in comments. We'll discuss comments in more. Returning to the guessing game program, you now know that mute guess will introduce a mutable variable named guess. The hmm, the equal sign tells Rust bind something to the variable now. Right of the equal sign is the value that guess is bound to, which is the result of calling string new, a function that returns a new instance of a string. String is a string type provided by the standard library that is growable. That is a growable. UTF-8 in bit of double colon. I say colon, double colon. Syntax in the double colon new line indicates, or I can say colon colon. I can say colon. Line indicates that new is an associated function of string type. An associated function is a function that's implemented on a type. In this case, string. The new function creates a new empty string. You'll find a new function on many types because it's common name for a function that makes a new kind. Hmm. In full, the let mute guess equals to string new line has created a mutable variable that is currently bound to a new empty instance of a string. Ew. Yes. Receiving user input. Recall that we included the input output functionality from the standard library with use stdio on the first line of the program. Okay. Now we'll call this stdin function from hi Daksh. How are you? Welcome. The first line of the program. Now we'll call the stdin function from the IO module, which will allow us to handle user input. Okay, stdin.read line and mute guess. If we hadn't imported the IO module with use stdio at the beginning of the program, we could still use the function by writing this function call as okay, or complicated. I'm doing great, bro. Living my life. How about you? Oh, what is it about? What kind of game? Those are the best kinds, man. I love horror games. Resident Evil forever. So are you building it in Unity, something else? Oh, my Discord link isn't working. Maybe it expired, man. I put it there a long time ago. I'll refresh it when I go to break, okay? Yeah, and what programming language do you use? Is it C sharp? Nice. And I've never ever touched C or C++ plus plus or C sharp ever. I don't even know the syntax, which is not a good thing being a developer. I would like to learn someday. How do you compare it to other languages? I mean, if you have ever used other languages, is C sharp more fun, difficult, easy, complex? What do you say? Really? In comparison to what? C, C plus plus is a low level language, man. Trav thinks it's unfun. Why do you think so, man? Again, I don't have any context here. Hmm. Because is it because it's a kind of primitive kind of language? Minefield. Nice comparison tabs. Um, yeah, I mean, uh, that's what Rust tried to solve, as far as I understand. Tried to negate those kind of errors, save these pitfalls. Oh man, 2 a.m. Okay, that is very strange. I mean, production things are really stressful. Me, I am from India, man. For anything, I am on call for. I advocate for rest, so I don't often get woken up in the. Good for you, man. Good for you. Rest for the win. Oh, same. Well, country bros, man. Okay. Let's continue here. Where were we? Yeah. Next, the line dot read line and mute guess calls the read line method on the standard input handle to get input from the user. We're also passing a mute guess as the argument to read line. Tell it what string to store the user input in. Okay. We call this for taking input from a read line. Okay, and store it in here as the argument to tell it what string to store the user input in. The full job of read line is to take whatever the user types into standard input and append that into a string without overwriting its contents. So we therefore pass that string as an argument. The string argument needs to be mutable so the method can change the string's contents. Yes, yes. The and indicates that this argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. Let me read that again. The and indicates that this argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that into memory multiple times. Okay, references are a complex feature, and one of Rust's major advantages is how safe and easy it is to use references. You don't need to know a lot of those details to finish this program. Yeah, for now, all you need to know is that, like variables, references are immutable by default. Okay, okay, it's referencing yes here. For now, all you need to know is that, like variables, references are immutable by default. Hence, you need to write and mute guess rather than guess to make it mute. I thought you need to write whatever kind of if it wasn't mutable, then it's it. But I thought it's blind, but it's chapter 4 will explain references more thoroughly. It is a reference, but I like calling it a borrow and an immutable borrow and mute. Okay, so if I have a function taking and T, I'm asking to borrow a read-only view of that T data. So if you don't add mute to the reference, you can read it but can't write it. That makes sense. Thank you, Tom. Nice. Hey, handling potential failure with result. We're still working on this line of code. We're now discussing a third line of text, but note that it's still part of single logical line of code. The next part is this method, but expect failed to read line. We could have written this code as read line mute guess.expect. Okay. However, one long line is difficult to read. Best to divide it. It's often wise to introduce a new line and other white spaces to break up long lines when you call a method with the dot method syntax. Yeah, they do that in JavaScript as well. Oh, here. Thick. Maybe here. As mentioned earlier, read line puts whatever the user enters into the string we pass to it. Okay, this is read line we passed here. Hmm. But it also returns a result value. Result is an enumeration, often called an enum, which is a type that can be in one of multiple possible states. We call each possible state a variant. Yes, I'm familiar with the enums, TypeScript. Okay, chapter 6 will cover enums in more detail. The purpose of these result types is to encode error handling information. Results variants are OK and error. The OK variant indicates the operation was successful and it contains the successfully generated value. The error variant means the operation failed and it contains information about how or why the operation. Values of the result type, like values of any type, have methods defined on them. An instance of result has an expect method that you can call. If this instance of result is an error value, expect will cause the product to program to crash and display the message that you passed as an argument to expect. Rust's enums are where the power of the language comes through. Once you get used to tagged unions, you tend to miss them in languages and don't have easy ways to model them, in my opinion. Okay, right. I guess we'll find out. Okay. Um, if this instance of result is an okay value, expect will take the return value that okay is holding and return just that value to you so you can use it. In this case, the value is the number of bytes in the user's input. If you don't call expect, we call expect here. Okay. If you don't call expect, the program will compile, but you'll get a warning. Rust compiler likes to give warning. That I know about it. Compiling guessing game warning unused result that must be used. Okay, if you don't add expect. Okay. Now this result may be an error variant which should be handled. Note only would help you select know the resulting value. You know, the moment I start understanding error, errors in the terminal or wherever they come out is the moment I feel like I have started really understanding programming. What do you think? Hmm. First warns that you haven't used. There's another warning. Okay. Guessing game, bin guessing game, generated one warning, finish step profile. Okay. First warns that you haven't used the result value returned from read line, indicating that the program hasn't handled a possible error. The right way to suppress the warning is to actually write error handling code, but in our case, we just want to crash this program when a program occurs. So we can use expect. You'll learn about recovering from errors in chapter 9. Okay. Printing values with println exclamation placeholders. Aside from the closing curly bracket, there's only one more line to discuss in the code so far. Println. You guessed. Yes. What is this? How do you place this inside string? Would this read the value of guess when it changes? This line prints the string that now contains the user's input. The curly braces set of curly brackets is I say braces, I say brackets is a placeholder. Think of curly brackets as little crab pincers that hold a value in place. Makers of Rust really like crabs. Nice. Gives it a lot of personality, in my opinion. When printing the value of a variable, the variable name can. Why do I lost it every time? Here. When printing the value of a variable, the variable name can go inside the curly brackets. When printing the result of evaluating an expression, the place empty curly brackets in the format string. Then follow the format string with a comma separated list of expressions to print in each empty curly bracket placeholder in the same order. Okay, printing a variable and the result of an expression in one call to println would look like this. What did it say? Printing a variable and the result of an expression in one call to println would look like this. Okay, we've got one variable let x equals to 5, second variable let y equals to 10, println exclamation X equals to curly brackets x and y plus 2 equals to um okay, empty curly brackets y plus 2, and we expect this to get here. Yeah, that's what it says. This code would print x equals to 5 and y plus 2 equals 12. Hmm. Okay. Testing the first part. Let's test the first part of the guessing game. Run it using cargo run. Finally. I was waiting when would I get to run it. Guess the number. Please input your guess. Bedtime. 22. You guessed 22. Like a charm. I should take a break. How long is it? How much of this chapter is left? Quite a lot. I'll take a break now. All right, we're back. Let's see, where did we find? Okay, testing the first part. Let's run the first part of the guessing game. Run it using cargo run, and I did. Let me power the chat. About the chat from here. Take this outside. Cool, cool, cool. Yeah, this much. Okay, where were we? So we ran cargo run. Yeah, here. We got this. Guess the number. Okay. At this point, the first part of the game is done. We're getting input from the keyboard and then printing it, generating a secret number. Okay. Next, we need to generate a secret number that the user will try to guess. The secret number should be different every time so the game is fun to play more than once. We'll use a random number between 1 and 100 so the game isn't too difficult. Rust doesn't yet include random number functionality at library. However, the Rust team does provide a rand crate with said functionality. Using a crate, to get more functionality. Remember that a crate is a collection of Rust source code files. Hmm. The project we've been building is a binary crate, which is an executable. The rand crate is a library crate which contains code that is intended to be used in programs and can't be executed on its own. Cargo's coordination of external crates is where Cargo really shines. Before we can write code that uses rand, we need to modify the cargo.toml file to include the rand crate as a dependency. Once again, Cargo's coordination of external crates is where Cargo really. Okay. Before we can write code that uses rand, we need to modify the cargo.toml file to include the rand crate as a dependency. Open that file now and add a following line to the bottom beneath the dependency section header. That cargo crate created for you. Be sure to specify rand exactly as we have here. With this version number or the code examples in real main. Okay. Hmm. Uh, doing how to use. Let me get a light. Second. Okay. Hmm. I switched to my laptop. So work now. Control C. And we'll do cat again. Now we need to do rand equals to double quote 3.85. Why am I doing cat? I don't know. I like it. And then you do control D. And you have edited the file. check. We can do cat cargo thermal. Oh, oh. Hmm. Now, in the cargo toml file, everything that follows a header is part of the section. That section that continues until another section starts. In dependencies, you tell cargo which external crates your project depends on and which versions of those crates you require. In this case, we specify the RAN crate and the semantic version specifier 0.8.5. Cargo understands semantic versioning, sometimes called SEMVer, which is a standard for writing version numbers. The specifier 0.8.5 is actually shorthand for this, which means any version that is at least 0.8.5 but below 0.9.0. Okay. Cargo considers that these versions to have public APIs compatible with versions 8.5, and this specification ensures you'll get the latest patch release that will still compile with the code in this chapter. Any version of 0.9.0 or greater is not guaranteed to have the same API as what the following example uses. Now, without changing any of the code, let's build the project as shown in listing 2.2. Okay, cargo build. Sometimes you tell me to do cargo run, then you tell me to do cargo build. It is confusing. I know I'll get it. Hmm. We get the exact same result. Your copy rates somewhat. You may see different version numbers, but they will all be compatible with the code thanks to SEMVer, and different lines depending on the operating system, and the lines may be in a different color order. When we include an external dependency, Cargo fetches the latest versions of everything that dependency needs from the registry, which is a copy of data from crates. Net table. Where's my phone? Sorry. Saying cargo run is to cargo run is do a build. If needed, then run the binary. Cargo build is just build the binary. Cargo check is just run the type checker on this, but don't produce an output like the binary. Oh, check is type checker. Okay, I get it. I get it. Cargo test and cargo check tend to be the most common used. In my opinion, run unit tests and check if your code still compiles, but don't make a new binary every time. Makes sense, yes. Why would you? Unless you're getting errors. Yeah, nice, nice. Thank you, Top. Okay, crits.io is where people in the Rust ecosystem post their open source Rust projects for others to use. After updating the registry, Cargo checks the dependencies section and downloads any crates listed that aren't already downloaded. In this case, although we only listed RAND as a dependency, Cargo also grabbed other crates that RAND depends on to work. After downloading the crates, Rust compiles them and then compiles the project with the dependencies available. I need to read that. After updating the registry, cargo checks the dependencies section and downloads any crates listed that aren't already downloaded. Okay, okay. In this case, although we only listed RAND as a dependency, cargo also grabbed other crates that RAND depends on to work with. Okay. After downloading the crates, Rust compiles them and then compiles the project. Hmm. While the dependencies, with the dependencies available. Okay, makes sense. If you immediately run cargo build again without making any changes, you won't get any output aside from the finished line. Okay, let me test that. Okay, correct. Cargo knows it has already downloaded and compiled the dependencies, and you haven't changed anything about them in your cargo.toml file. Cargo also knows that you haven't changed anything about your code, so it doesn't recompile that either. With nothing to do, it simply exits. All right. If you open the source main.rs file, make a trivial change, and then save it and build again, you'll only see two lines of code, lines of output. Cargo build, compiling, guessing. Let me see. I'll do the touch thing again. On touch, source main.rs, and then we'll cargo build. Yes, two lines only. Compiling finished. These lines show that cargo only updates the build with your tiny change to the source main.rs file. Your dependencies haven't changed, so cargo knows it can reuse what it has already downloaded and compiled for those. Okay. Ensuring reproducible builds with the cargo.log file. Yeah. Reproducible builds. Let's read what those are. Cargo has a mechanism that ensures you can rebuild the same artifact every time. Cargo has a mechanism that ensures you can rebuild the same artifact every time. You can, every time you or anyone else builds. Okay. Cargo has a mechanism that ensures you can rebuild the same artifact every time you or anyone else builds your code. Cargo will use only the versions of the dependencies you specified until you indicate otherwise. For example, say the next week version 0.8.6 of the RAND crate comes out, and that version contains an important bug fix, but it also contains a regression that will break your code. To handle this, Rust creates the cargo.log file the first time you run cargo build. So we now have this in the guessing game directory. Okay, it's like package.log.json in JavaScript. So if I do ls, we've got cargo log. Okay, nice. When you build a project for the first time, Cargo figures out all the versions of the dependencies that fit the criteria and then writes them to the cargo.log file. When you build your project in the future, Cargo will see that the cargo.log file exists and will use the versions specified there rather than doing all the work of figuring out versions again. This lets you have a reproducible build automatically. In other words, your project will remain at 0.8.5 until you explicitly upgrade thanks to the cargo log file. Because the cargo log file is important for reproducible builds, it's often checked onto source control with the rest of the code in your project. Updating a crate to get a new version. When you do want to update a crate, Cargo provides a command update which will ignore the cargo log file and figure out all the latest versions that fit in your specifications in cargo. Do you call it TOML or TOML? What do you call it, TARP? Cargo will then write those versions to the cargo.log file. In this case, Cargo will only look for versions greater than 0.8.5 and less than 0.9.0. If the RAND crate has released the two new versions, this and this, you would see the following if you ran cargo update. Okay, cargo update. Hmm. Cargo ignores the 0.9 point release. Did I get this? Okay, crates.io index here, locking one package, any package. Because I run Rust update, I don't know. Cargo ignores the 0.9.0 release. At this point, you would also notice a change in your cargo.log file, noting that the version of the RAN crate you are now using is 0.8.6. To use RAN version 0.9.0 or any version in the 0.9 series, you'd have to update the cargo.toml file to look like this instead. Okay. um, if we cat the cargo.toml, oh, we still got 0.8.5. So the next time you run cargo build, cargo will update the registry of crates available and reevaluate your RAN requirements according to the new version you have specified. There's a lot more to say about cargo and its ecosystem, which we'll discuss in chapter 14, but for now, that's all you need to know. Cargo makes it very easy to reuse libraries, so Rustaceans are able to write smaller projects that are assembled from a number of packages. Hmm. Oh man, was I talking on mute this whole time after coming from break? Maybe. It's on now. Generating a random number. Let's start using RAN to generate a number to guess. The next step is to update source main.rs as shown in listing 2.3. Okay. What did they change? So we had this. We didn't have this. Secret number equals to RAN thread rng.gen range 1 2 equals to 100. Then secret number is this. And print, please input your guess. Let me guess string. Or let mute guess string new io cin dot read line mute guess expect will read. You guessed this. How does it matter? I'll need to run it. Okay. Write and quit. Then what? First we add the line used ran rng. I see that. No. Here. It again. I can keep referencing. Okay. The RNG trait defines methods that Random number generators implement. Okay, RNG is random number generator. And this trait must be in scope for us to use those methods. Chapter 10 will cover traits in detail. Hmm. I need to get some water. Give me a minute. Okay. Hmm. The RNG trait defines methods that random number generators implement, and this trait must be in scope for us to use those methods. Chapter 10 will cover the traits in details. Next, we're adding two lines in the middle. In the first line, here. In the first line, we call the rand thread RNG um, function that gives us the particular random number generator we're going to use, one that is local to the current thread of execution and is seeded by the operating system. Then we call the gen range, okay, method on the random number generator. This method is defined by the RNG trait that we brought into scope with the use rand RNG statement. The gen range method takes a range expression as an argument and generates a random number in the range. The kind of range expression we're using here the takes the form start end and is inclusive on the lower and upper bounds. So we need to specify one dot dot equal 100 to request a number between 1 and 100. Okay. Note, you won't just know which traits to use and which methods and functions to call from a crate. So each crate has documentation with instructions for using it. Another neat feature of Cargo is that running the cargo doc open command will build documentation provided by all your dependencies locally and open it in your browser. If you're interested in other functionality in the RAN crate, for example, run cargo doc open and click RAN in the sidebar on the left. Really? What is it? Cargo doc open. Not here, man. No. Cargo doc open. Uh, where's RAN Chacha? Oh, here. One. Nice. 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 The second new line prints the secret number. This is useful while we're developing the program to be able to test it, but we'll delete it from the final version. Not much of a game if the program prints the answer as soon as it starts. Where? This one. Yeah, I was thinking, why is it printing the secret number? Because you need to guess it. Try running the program a few times. Cargo run. Why don't I open a new terminal? Not trying to do that. Trying to do this. Okay, 3D project slash guessing game and build what? Cargo run. Okay. Guess the number. The secret number is 26. Please input guess. Please input your guess. You guess 26. Hmm. Okay. You should get different random numbers and they should all be numbers between 1 and 100. Great job. Comparing the guess to the secret number. Now that we have user input and a random number, we can compare them. That step is shown in listing 2 to 4. Note that this code won't compile just yet, as we will explain. Okay. Is this? Okay. Go mode. Select all. Delete. Edit. Okay. 1 more file to edit. Quit anyway. Which file? First, we add another use statement that bringing a type called stdcmp ordering. That's it. Into scope from the standard library, the ordering type is another enum that has the variants less, greater, and equal. These are three outcomes that are possible when you compare two values. Then we add 5 new lines at the bottom that use the ordering type. The CMP method compares two values and can be called on anything that can be compared. It takes a reference to whatever you want to compare with. Here it's comparing guess to secret number. Then it returns a variant of the ordering enum we brought into scope with the use statement. We use a match expression to decide what to do next based on which variant of ordering was returned from the call to CMP with the values in guess and secret number. Let's see. Okay, we take secret number here and it will generate a secret number. Then we'll print it. Then we press input your guess. We guess string. Okay, now here match guess.cmp. We compare secret number to guess. Less println too small, ordering greater. Okay, this is a nice way to do it. Very small code, efficient. I mean, little code, not small. Okay. Hmm. A match expression is made up of arms. So an arm consists of a pattern to match against and the code that should be run if the value given to match fits that arm's pattern. Rust takes the value given to match and looks through each arm's pattern in turn. Patterns and the match construct are powerful Rust features. They let you express a variety of situations your code might encounter, and they make sure you handle them all. These features will be covered in detail in Chapter 6 and Chapter 19, respectively. Let's walk you through an example with the match expression we use here. Say that the user has guessed 50 and the randomly generated secret number is 38. This time is 38. When the code compares 50 to 38, the CMP method will return ordering greater because 50 is greater than 38. The match expression gets the ordering greater value and starts checking each arm's pattern. It looks like at the first arm's pattern, ordering less, and sees that the value ordering greater does not match ordering less. So it ignores the code in that arm and moves to the next arm. The next arm's pattern, ordering greater, is good, which does match ordering greater. The associated code in that arm will execute and print too big to the screen. Hmm. The match expression ends after the first successful match, so it won't look at the last time at the last arm in this scenario. However, the code in listing 2 to 4 won't compile. Let's try it. They said it won't compile. Why? Cargo run. Okay. Compiler has started fighting me now. Source main 24. 24, where's 24 here? Match dot match guess dot cmp secret number expected and string and found what found what found integer. Argument to this methods are incorrect. Note expected reference string, found reference integer. Method defined here. Then what is error try rust c explain E0308. Why am I doing this and not command C? X plus 1. Okay, plus 1 not a number, not a boolean, not a float. This error occurs when an expression was used in a place where the compiler expected an expression of a different type. It can occur in several cases, the most common being when calling a function and passing an argument which has a different type that the matching type in the function declares. Hmm, but I don't know. How did this happen? The secret number, a number, and it was expecting. Okay, it was expecting a string. Ah, gross. Why? What makes you think it is gross, tofu? Okay. We'll need to somehow convert this into string. Let's say the core of the error states that there are mismatched types. Rust has a strong static type system. However, it also has type inference. When we wrote let mute guess equals to string new, Rust was able to infer that guess. Okay. Well, how are you today? It also has type inference. When we wrote let me guess equals to string new, Rust was able to infer that guess should be a string and didn't make us write the type. The secret number, on the other hand, is a number type. A few of Rust's number types can have a value between 1 and 100. I32, a 32-bit number, U32, an unsigned 32-bit number, I64, 64-bit number, as well as others. And what is this? Hmm. You need to specify these kinds of things every time you take an integer. So it says, unless otherwise specified, Rust defaults to an I32, which is the type of secret number. Unless you add type information elsewhere, that would cause Rust to infer a different numerical type. The reason for the error is that Rust cannot compare a string and a number type. Ultimately, we want to convert the string. Yeah, that's the point. The program reads as input into a number type, so we can compare it numerically to the secret number. We do so by adding this line to the main function body, where let guess u32 guess.trim.parse.expect. What? What would it do? But how is this related to this? Hmm. The line is this. We created a we created a variable named guess. Um, but wait, doesn't the program already have a variable named guess? Yes, it did. Here. It does, but helpfully, Rust allows us to shadow the previous value of guess with a new one. Shadowing lets us reuse the guess variable name rather than forcing us to create two unique variables such as guess string and guess. For example, we'll cover this in more detail in chapter 3, but for now, know that this feature is often used when you want to convert a value from one type to another type. Okay, okay. We bind this new variable to the expression guess.trim.parse. The guess in the expression refers to the original guess variable that contained the input as a string. The trim method on a string instance will eliminate any white space at the beginning and end, which we must do before we can convert the string to a U32, which can only contain numerical data. The user must express enter to satisfy read line and input their guess, which adds a new line character to the string. This is a lot. This is a lot. For example, if the user types 5 and presses enter, guess looks like this 5 enter. The n represents new line. The trim method eliminates n or rn, resulting in just 5. Okay. The parse method on strings converts a string to another type. Here we use it to convert from a string to a number. We need to tell Rust the exact number type we want by using let guess u32. The colon after guess tells Rust we'll annotate the variable's type. Rust has a few built-in number types. The U32 seen here is an unsigned 32-bit integer. It's a good default choice for a small positive number. You'll learn about other number types in chapter 3. Okay. Additionally, the U32 annotation in this program and the comparison with secret number means Rust will infer that secret number should be a U32 as well. So now the comparison will be between two values of the same type. The parse method will only work on characters that can logically be converted into numbers and so can easily cause errors. If, for example, the string contained an emoji, there would be no way to convert that to a number because it might fail. The parse method returns a result type, much as the readline method does, discussed earlier in handling potential failures with result. We'll treat this result the same way by using the expect method again. If parse returns an error result variant because it couldn't create a number from the string, the expect call will crash the game and print the message we give it. Okay. If parse can successfully convert the string to a number, it will return the OK variant of result and expect will return the number that we want from the OK value. Let's run the program now. I didn't understand much of what's here, but some of it. Okay. We didn't add that line. Da, da, da. Hmm. Select, delete, copy, paste, right. Run. The secret number is 26, 3, too small, 30, oh, 30, too big. Working fine. Okay. I think this is enough for tonight. We'll continue tomorrow. Alright, everyone. See ya.